And yeah, he holds a master's degree in computer science with focus on cognitive systems from the Technical University Berlin. And yeah, we'll look forward to join him on 2 vision language adventures. So welcome in on stage. Thank you.
Thank you. I just have to get this started. I've got 2 vision language adventures for you today here. I'm Johannes. As Rafa, as I said, I've got this term AI storyteller that I like to describe myself with, because I like to tell stories, and I also like AI, and I thought maybe I can combine those. And I tried this, and afterwards you can judge if it is good or, well, not. But first, maybe a bit about me. As Rafa said, I'm a data scientist at Celebrate company. That's a company mostly in Germany. So we are in Germany and in France, actually. And well, we're mostly selling what our CEO likes to tell, bespoke paper products, right? So that's stuff like wedding invitations, calendars, photo books, stuff you can order that can be printed, right? And that you can customize yourself. There we are a really small data science team, two people, so just one colleague and me. That makes both of us mainly generalists, so we have to do everything, right? Like full stack, we discover stuff, we have to deploy it, we have to train stuff, monitor, we do everything basically. But my real passion is actually in computer vision, and that was also like one of the main focus things when I did my Master's of Science. I'm also a Hugging Face fellow, so some of you might know the company Hugging Face, I guess. And there's this fellowship program where they just ask people from the community that are really active, that do stuff in the community, if they want to be in the fellowship program. And then we've got this nice Slack channel, and you get cool merchandise like this pin. Today I've got this little pin right here. It's very cute. Yeah, but I don't get paid by them. I'm not financially affiliated with them, right? And I also like to say I'm kind of an AI educator. So we created this community computer vision course last year in the Hugging Face community. You can check it out on Hugging Face site, actually, where we had like over 100 people contribute to one computer vision course, and I coordinated everything and led the whole thing. And I was a speaker already at like PyData London, EuroPython, Python Pizza Hamburg, which was funny, good pizza, and PyCon Africa just 3 weeks ago. That's great. I recommend to go to the next PyCon Africa. It will be in South Africa next year. It's a great experience. Yeah, I think that's enough about me. And now we will start with the first story. And it is called Sea of Memories. Right. So, a little bit poetic here. I will start. So, in a land not too far away, there was a small town. A bit like Rapperswil, right? When I saw Rapperswil and I saw this slide, I was like, hey, it's here. And in this town, there are fishermen. And fishermen are famous all over the world because they're not fishing for animals, but they are fishing for memories. All right. So what happens is people from all over the world send their letters to this little village, town, whatever, and the fishermen pick it up, and in these letters, there's written like, oh, I'm looking for this old memory of my cat or my dog, right? And the fishermen set out to sea, to the sea of memories, and they start looking for it. So basically, the task is we've got some letters, some text, and we want to retrieve old memories in the form of photographs, pictures, right? But what's in between? I mean, there's something, right? There should be something in between. And the fishermen are smart men. Even though it looks old, they have internet. They can go on the internet and they order a machine. Wait, yeah, this one. Ha. CLIP. Well, in reality, CLIP is a machine learning model you might have heard about. For the sake of the story, let's assume it's also like a machine. So CLIP was created by a company, let's call it not really OpenAI.inc. And it is pretty good, actually, because it can combine text and images. So it consists of two main parts. There is a vision encoder, which is like your top part, and there is a text encoder. Let's assume it's the lower part. So what they can do is really they can feed text and they can feed images in. And when the fishermen bought this thing, it was pre-trained, right? They didn't have to train anything. Really, it was good. But actually, the training is really interesting. And just one quick slide about it, because it seems so simple and so effective. So what happened in the training was that they had like a lot of images and a lot of text at not really OpenAI. And well, we don't know where these came from, right? They never told. They probably will never tell. But they had like a huge load of images and text, like I think 400 million. That was at this point the biggest there ever was as a data set. And they just said like, okay, we're gonna encode everything. Like for each text, we have one of these blue squares. For each image, we have one of the red squares. And then we're just gonna figure out like with the contrastive loss, we compare, okay, what fits to which one, right? So with the contrastive loss, in the end, they figured out, okay, like something like this. Like there's an orca jumping out of the water. There's a giant wave breaking, a lighthouse staying among rocks. So now the fishermen have a way to actually fit text to images, right? So that helps. They can take the text from the letters and they can feed it into CLIP. Now CLIP will tell them, okay, well, images like, for example, this orca might be where you want to go. But then we have to find out where is that actually. So as a first step, they have to embed a lot of images to actually find out where they should go for fishing, right? So before they can really start with the text, they need to embed a lot of images. And they need to store all this information from images, and they get another device, a big chest. And here I call it data sets because there's a great library by a company called Hugging Face, which you might have heard of. It's pretty cool, actually. It's open source library, right, on GitHub. And it is like a really good way to store your data. So you can, it's basically a wrapper around stuff like data frames, or even when you have like local data and you want to upload it, for example, to Hugging Face Hub or wherever, or just want to manage it well, you can use data sets. So what you can do there is, as I said, right, you can have local files that you load into data sets. You can have data structures like digs or data frames that you get in there, or you can even just download pre-built data sets from the Hugging Face Hub. So it's pretty good for holding data, to query data. It has a pi arrow under the hood, so it's pretty fast. And there's another part. Again, there's two parts. And that's the Facebook AI similarity search. Or in short, it is FAISS. I would say FAISS. I don't know. Well, it's one of these things you can only pronounce wrong, I guess. So for me, it's FAISS. It was built by Meta, but it's completely open source. A lot of stars. Really popular and really lightweight, actually. So what you can do with FAISS is that you can put in data embeddings, and in the end, they will give you similar data points. That's great, right? Okay, now we have like a lot of components, and you might think, okay, but how does this work now? And that's where the next slide comes in. So the initial embedding that I mentioned, right? So the first step the fishermen have actually to do is that they have an input, like somewhere in the sea. They just go there to different points, and they grab some of the images, and they put it into the vision encoder. The vision encoder creates embeddings. These embeddings go to the data sets. So then we have a lot of embeddings in the data sets, and the data sets then we simply call create index. Actually, that's a method. If we have time, I will show you code afterwards, right? So there could be code if I'm fast enough. But then we have like an indexed embedding, and we can go to the next step, which is that we take the letters of the people, like picture of an orca, put that into text encoder, get another embedding to the data set, and again, with the embedding, we say, hey, FAISS, can you give us like close neighbors? And hopefully it will give us one, like this orca, right? And yeah, that's the retrieval workflow basically. And that's all we need for it. It's pretty cool. I mean, there are alternatives to CLIP, right? I mean, it's 4 years old, almost 5 years old. That's like an eternity in machine learning years, right? That's like 100 years in real human years. So there are alternatives like CLIP is, I guess, the best performing right now. EVA CLIP, pretty good. And actually my favorite is Mobile CLIP by Apple. But they're all MIT licensed actually. So you can use them for your work. You can use them for whatever you want. Yeah. So they're pretty cool. You can check these out. And there are dataset alternatives as well, right? So vector stores. But I guess most people also have heard about vector stores. There are like so many. And here are some of them. I really like Quadrant. Actually, another name you can only pronounce wrong, I feel. But they're from Berlin, so like a German startup. It's pretty good, actually. It's rare. And this VV8, Marco, LaunchDB, if you feel like it, check them out. Right. So, yeah. So for the first story, that's it already. That was pretty quick. And we're getting to the second story, the mystery of the jungle. Right. What is that? Wait a second. So imagine you are part of a team of research scientists. Probably some of you are, so you don't have to imagine that hard. And with your group, you're tasked to go to the wilderness, like a jungle. And you're supposed to monitor like the population of animals. So yeah, just find out what kind of animals are there around. Yeah, how many are there? And probably your approach would be to put up something like camera traps, right? So you put up a camera trap here, there, at some fixed points where you feel like, oh yeah, that's probably where animals go. So let's put some cameras here and there. So in the end, you get nice pictures of a lot of animals, daylight, nighttime, all kinds of stuff. But while going through the pictures, you see something strange. There is an animal you've never seen before. It looks like a huge bear with some horns. So you ask like your colleagues, hey, have you seen this? What's that kind of animal? Have you ever seen it? Nobody really knows. But now you've got like these millions of images probably from all your data. And you think, okay, somehow we need to figure out what this is. And if it's just like some illusion kind of thing, or is it real? So we need more pictures, right? If you find more pictures of it, it might really be real and we can find out where it lives. So what do we need to do now? We need to cluster. Actually, you might think it's quite similar to similarity search, right? So we need to find like similar images. But the hard thing here is now that you've got like these images that look really similar, like of the birds in the upper left corner and then lower left, there's a boar, right? And the background is quite similar, just it's different animals. So similarity search could work, absolutely. Depends a bit on the model you use for the embeddings, but it might also fail, right? So most likely the problem is that stuff clusters together that looks similar and stuff that looks different goes there, even though there might be a boar in the nighttime, but the boar in the nighttime might be far from like the boar in the daytime. And the boar in the daytime might be closer to the birds at daytime than the boar in the nighttime. That's difficult. So there's another way to get information from images, and that's also related to vision language models. And this one is a really fresh one, I would say. It's just some months old. It's called Florence 2, created by a Microsoft team. It's also MIT licensed, right? You can also use it for everything you want. You can find weights on the Hugging Face Hub, and the paper is also there. Yeah, and they put a hydra there. So like a snake with many heads. And that is because for me, this Florence 2 model is always like a bit, a monster with many heads, really, right? So it can do a lot of stuff at once. It can do OCR, captioning, visual grounding and object detection, detailed captioning, classification, segmentation, region proposal. You might not know what all of it is, but it's a lot of stuff. And there are not many models that can do this. And how they managed to actually train a model like that is, again, mainly related to data. Data is all you need, right? I guess most people that do data science know that in the end, data is still one of the most important parts. And what they did is that they created their own data set where they had not only images and like a description for it, but they also put coordinates into the description. So like for a person, and then they put like in brackets, they put like the coordinates of that person in that image. So it's like a lot of work actually, but they did the work for us. And then created the data and trained their model with it. And they created some more data and even more data. And they put it all into this model. They haven't released the data set yet. They still want to do that. So it should be out hopefully still this year, because it will be interesting to see. But in the end, it turned out that this model is really good at a lot of tasks. But for now, we only need one, actually. We only need captioning. Okay? So captioning, I guess it's pretty easy. We just take a picture and we want a description of that picture. So we say, okay, Florence 2, please give us a description. It says, a white boar walking through a forest on a trail camera. That's cool, right? I mean, it is a white boar walking through a forest on a trail camera, but maybe we need more information. Luckily, it is able to do detailed captioning. So now, the image shows a white boar walking through a forest. The boar is dark brown in color and appears to be walking on a bed of fallen leaves and twigs. It is walking towards the right side of the image, with its head down and its mouth slightly open. The background is filled with trees and foliage, and there's a small bird feeder hanging from one of the trees. I don't see it, but it's okay if it's you can look for it. Maybe you see it. The image is taken from a distance, and the boar's body is slightly blurred, indicating that it is in motion. And that was pretty impressive. When I got that, I was like, okay, that's more information than I would ever like to write about an image. Like, I would never want to do a labeling job and write that much information. So it's cool that there are models that can do this now, right? Of course, we don't have the guarantee that everything is correct. Okay, but yeah, I mean, that's something we have to live with now. Okay, so now our approach is that we have like all these images and we create captions for all of them, very detailed captions. But we still need to cluster them somehow, right? Like we've got all these many texts now, and we need to cluster them. And now we're heading into the realm of natural language processing. So we turned our backs on computer vision, which I don't like to do often, but sometimes it's better. And now we somehow have to do clustering with the text. And I'm sure there are many ways, and probably some of you may know more than me. But there's one that I especially like, and it's called topic modeling, right? So for topic modeling, this thing is that there is like a factory, I would like see it like this, and you put all the text into this factory, and the factory actually figures out by itself like how many bins in the end it will produce, right? Because when we have something like a classification, we would have to know like, okay, how many text or like how many classes are there, how many animals are we looking for, but we don't really know, right? We don't have any labels and there's like millions of data points. We have no idea how many classes we are looking for. So topic modeling is pretty handy in the term that it can just create more classes from the descriptions it has seen, right? It tries to analyze the images and then the image texts now, of course, from a text it has seen, and then come up with classes for that, topics, right? So you can imagine that when it's like a newspaper data set, that's pretty popular, and then you just throw in all kinds of articles and it tries to find the topics, like there's sports, probably a newspaper, right? Then there's like politics, and it comes up with those topics by itself. And there's another really great library for that. It's called BERTopic by Martin Grotendorst from the Netherlands. And he created that. It is pretty cool and easy to use. And with BERTopic, we can do exactly that, right? We just throw in texts and it will give us like our classes, our topics. We can also say like, okay, but we have like an idea of classes. So maybe you can like take these and just see like how many documents fit in each category, right? And then it will try to do that as good as possible. It can also handle images, actually. So that's also pretty cool because then we can just connect text and images directly and it will give us the connection. We don't have to do much post-processing then. And because we live in the times of large language models, of course, it can also connect to a large language model. And then you get nicer topics, actually, because mostly with these old natural language processing methods, the topics sometimes are a bit difficult to read, let's say. You wouldn't want to give it out to like a customer when he's create without LLMs. So LLMs are pretty good at coming up with cool names for the topics. We know they are creative, right? Yes, so basically the workflow now would be, we have our images, we give it to Florence. Florence creates all the captions. Then we give the captions to BERTopic. And in the end, we get out all our great topics. Yes. Okay, that's the end of the second story. Now a little conclusion. So I'm a big fan of vision language models, right? I feel like the step of bringing together images and text was really, really important. And actually both sides benefit because I feel like they're just making each other smarter, right? So there's always stuff like hallucinations, like stuff language models get wrong, for example. And then it can help actually to look at the image and have a grounded language model, right? So that means it actually has some computer vision component that looks if the stuff it says is really in the picture. So this is some way to mitigate hallucinations. And on the other end, the text information helps a lot in enabling object detectors, for example, to do something like zero-shot detections, right? Just create zero-shot detection performances by models that have been trained like CLIP and that can just detect stuff they probably have never seen or never been trained for to classify. So yeah, it's just a beneficial relationship. Okay. And actually both things I've talked about today, so like CLIP and then similarity search and the clustering with BERTopic and the captioning, I've used both of them in my daily work and they really work amazingly. And the best thing I think is that they are not like real heavy or difficult to deploy because they are rather small. So Florence 2 is quite a small model. It has less than 1 billion parameters, right? So in times of, 80 to 100 billion models, that is pretty small. I can run them on my laptop here, right? It takes a while, but I can run it without any memory issues. And yeah, that is pretty helpful. And yeah, overall, my main goal here was to show you that there are many ways already to connect text and image, and there's a lot to explore there are so many great models already out there, and I mean, every day basically new ones. And yeah, I hope when you get back, maybe one day in your daily work life, you think like, maybe that's something for a vision language model. Yes. Thank you.
All right. We have time for questions, so raise your hand. There's already a raised hand there in the middle. Where are the mic? On its way.
Hey, thank you. I was wondering about, in the first story you mentioned that we were trying to find from text, we're trying to find similar images through the CLIP model. The CLIP model has a bit of like a Achilles heel where the text encoder has around like 70-ish token limit. What would be a good way to get around that? Because I would imagine sailors like to be very verbose with their description. So, you know, when you have long descriptions of something.
Yes.
Yeah.
I think. That's true. So yeah, the text encoder is limited. That's right. I mean, there are other models that can like do it better already. That we won't wait, just not choose like the normal CLIP, but one of the more specialized or like newer models maybe. Another thing that just came to my head again was using like a language model to shorten the caption maybe, the text, because in the end, it might be enough. Like the 17 tokens, if you really just want to stay with that model, right? You need some way to shorten that, and then again, I would see language models probably as a good way right now to just summarize.
Cool. Thank you.
All right. Are there more questions? Don't see any raised hands so far. I have a question, maybe a layman question, because I'm not really that much into AI, but so you basically combine just multiple tools and glue them together, to paraphrase it a bit. So will there be, like in the future, a model that just has all this ingrained already, so that it's basically able to do that in one step?
You mean like stuff like the similarity search, so you don't have to take like the first model and then like the data sets and then indexing everything? I'm not sure. I don't know of any that would do like. Well, the thing is, the models mostly produce the embeddings, right? And like this similarity search, like the FAISS, for example, it is specialized in creating indexes that are just fast to browse, to search, right? And that's like a different task to what most models would do. So I don't think that this will be unified. For the second one, with the topic modeling, I can't think of anything right now.
Okay. All right. Are there further questions in the audience? Doesn't seem like it. Okay, so thank you very much.